Now we're going to calculate definite integrals geometrically. Okay, so first we're going to start with the total area. There we go. Okay, so best way to do it is just with an example. Let's say if we want to find the total area, between the curve of the function f of x equals negative 2x plus 4, and the x-axis, over the interval from 0 to 9. Okay, and for some of them they gave you the graph, and for some I think they left it to you, the graph. But the graph just looks something like this. This kind of goes there to there. Okay, so that's 1, 2, 3, and it intersects at 4. And this, actually it should have been over a little bit more, because this intersects at 2. So this should have been a steeper slope. There we go. So you have 1, it intersects at 2, 3, 4, 5, 6, 7, and it goes all the way to 9. Eight and 9. And this, when it gets to 9, it goes down to negative 14. Uh-oh. Okay, so we want to find the area between 0 and 9, which means we want to find the area here, which we'll call this area number 1. And this would be our area number 2. So everything in here.
Do we have to draw the graph?
Oh, no, you don't have to. Uh-oh, sorry about that. Like I said, I think with most of them, they actually give you a picture of the graph, so you don't have to figure it out.
Does it really make a difference in solving it by actually seeing the graph? Or?
A little bit, only because for this one, you just have to remember the area of a triangle. So if we have the area of a triangle is 1/2 the base times the height. Okay, so this one, we know our height is 14. Even though it's negative, it's still a height of 14. And our width here is 2, 3, 4, 5, 6, 7, 8, 9. So it's a width of 7, a base of 7. For this one, you have a base of 2 and a height of 4. So to find your total area, you just add them together. So your total area is just going to equal A1 plus A2. Okay, so our area of the first triangle is 1/2 times the base, which is 2, times the height, which is 4. Okay, so that just equals 4.
So we would need to draw it then.
I mean, if you can figure out a way to do it without drawing it, then you can, because some people might be able to look at it and go, okay, I can see how that picture it and do all that, but I'm not that smart, so I had to draw it. So the second area, which is 1/2 times 7 times 14. 14 divided by 2 is 7, so you end up with 7 times 7, which is 49. So the first plus the second is just 49 plus 4, which is 53. Oh, square units. All right, so any questions on that one? And most of the homework problems I saw were linear, so you just use the area of the base times height. Doesn't really get any crazier of a function than that. All right, so again, we're calculating definite integrals geometrically. We'll clean that up some. But this time we're looking for the net signed area. Okay, and the net signed area is really just, because if you remember for the Riemann sum, it had to be a non-negative value for the area. So let's say if you had a graph that, let's say negative x squared, and move that over just a little bit more. Okay, so let's say this one goes that way, and this one goes same. Okay, so let's say this is our area here. Let's say we're going to some value here where this is our second area. The area below the x-axis will be subtracted. So you have the area from 0 to 2. Well, let's say in this one it's going to 2. Of f of x with respect to x. That's going to equal the limit, the sum from I equals 1 to n, f of ci delta x, which they're just going to make your a1 minus a2. Because remember, the whole, in the definition of a limit, or the integral definition, you actually had where it had to be non-zero. So for this area to be 0, if you wanted to add them together to get our total area, we'd have that. But we'd have to actually subtract any part of the area that's below the x-axis. And that would be our net signed area. All right, any questions on that one? All right.
So it's always A1 minus A2.
I mean, if you want to switch them up, you could, but it's
So
just,
with the upper minus.
yeah, but it's always going to be the upper minus lower. I'm the type, once I find something that works, I stick with it. Only so much memory space up here for me. Okay. Oh, anyone's still writing? All right. So let's say, for example, and for these, they do give you the pictures. So given the function f of x equals 2x plus 4, find the net signed area between our function and the x-axis. Didn't need that comma. Between -7 and 4. And the graph, see if I can draw this without completely messing it up. So -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, and 4. All right, so it actually go up 1, 2, 3, and 4. Those are your intercepts, so it actually goes through there. And for the sake of space, this goes up to 12, and this goes down to -10. Okay, so between -7 and 4, got to go down a little bit more. Curve that in because we're running out of space trying to draw this. Okay, so from -7 to 4, bring that up a little bit more. Okay, so this would be our area, and this would be our area. So we'll call that A1, and this is our A2. Straighten that up. Okay, so again, if we're looking for our base and our height, so you have -2, -1, 0, 1, 2, 3, 4. So this has a length of 6. Our height has a height of 12. So you go from -2, 3, 4, 5, 6, 7. So this has a length of 5. And this has a length of 7. Oh, yeah, 10. I don't know what I was looking at 7 for. 10. That's right. Okay, so we know area 1 is going to be 1/2 times the base, which is 6, times the height, which is 12. 6 divided by 2 is 3, so that gives us 36 square units, which you don't need the square units, but put it there anyway. Okay, and our second area is going to be 1/2 the base, which is 5, times the height, which is 10. 10 divided by 2 is 5. 5 and 5 is 25. Okay, so that gives us our A1 minus A2, which is 36 minus 25, which is 11 square units. Bless you. All right, so any questions on that one?
So the net sign is like the minus, while the
Yep, total area, you add both of them. And then net area, you subtract whatever is in the denominator. I mean, not denominator, below the x-axis. All right. Any other questions on this one? All right, so I'm going to stop there.